Welcome to textbook 4.2, which is cross product. Yeah, so in this PowerPoint slide is called the vector cross product. While finding the moment of force 2D, then straightforward. When you know the perpendicular distance is d, finding the perpendicular distances can be hard, especially when you're working with forces in 3 dimension. Yeah, so you cannot use the 2D method in your 3D. Yeah? So it's a bit different. Yeah, okay. So a more general approach to finding a moment of the force exists. This more general approach is usually used when dealing with the 3-dimensional forces, but can be used in 2-dimensional case as well. Yeah. This more general method of finding the moment of force uses a vector called the cross product. So we're going to do cross product. I know most of you have done this in your maths before. Once again, like what I have told you in your dot product, cross product and dot product is covered in calculus, so it will not be looked into detail in this lesson, statics. In this class, I only lecture you on how to use the cross product. So your knowledge of cross product should be actually good. Yeah. Okay. So in general, cross product are two vectors, yeah, between A and B. So it's like curling. Can you see? It's like curling. So the angle in between A and B, yeah, can be written as C equals to A cross B, which is equivalent to AB sine theta with the unit vector of C. Okay, so the resultant will be your thumb, which is going up, which is C. So A cross B will be C. Yeah, okay. So when you see cross product, what happens with cross product? I cross J will be K. So if I cross J, yeah, this side is positive, right? It will be positive K. If you I cross K, you're going this side, right? The answer will be J, but it's negative J. Okay, you have done this in your school in the maths before. Now I cross I will be 0. Yeah, but in dot product it is a bit different. Yeah, okay. So with that, you can actually form the matrix. Now this matrix is very important for me to check and to evaluate you during the test and final exam. This is what I check. Yeah, I don't check this part, I check this, and I check the final answer. So that's the most important, because this part is actually very mathematics. Yeah, how to solve it, how to get the answer. Yeah, this is very mathematics. I see this arrangement to see whether your concept is correct, and then I will look at the final answer. So that's how it works. Yeah, okay. And so in textbook, it is at 4.2. Yeah, this page here, you can find them in your textbook. Yeah. 4.2. Okay, so we have covered. So the negative side will, okay, another thing about cross product, you know about the law of operations of cross product itself. Yeah, A cross B is not equivalent to B cross A. Yeah, it will be reverse. Yeah, it will be negative. Yeah? So it's not that simple. You can just like just multiply. It's not multiplication. Yeah. Okay, so you see A cross B plus D will be equivalent to A cross B plus with A cross D. Yeah, it's one by one. It's not like combined. Yeah, okay. So these are the things that maths has covered. So there's the box that's very important. You have to pay attention there. Yeah. Okay, now let's look at the application in statics. Yeah, moment of a force vector formulation. Okay, so now, as what I've told you before, force times distance is moment. Yeah, force times distance is moment. That's for scalar. Now, when it comes to vector, it is not. It is similar to scalar, but it's not as same as scalar. So here we have got a bit different here. R cross F. What is R? R would be the distance. Can you see O is the axis of rotation or your reference axis? Okay, the distance of O to R. The distance of O to the force would be the R. Okay, then you can question me. Look at this, principle of transformability. Oh, this is the line of vector down there, but you have R1, R2, R3. R1, R2, R3 gives different coordinates, yeah, but then it's very unique. You take R1, you cross with F, it will give you the same answer as R2 cross with F and R3 cross with F or whatever R, as long as it is from O to the line of the line of action, which is the force itself. Okay, so this is the unique part of principle of transferability of moment. Yeah, Okay, so you want to find magnitude. It's very simple. You take the r, f sine theta, or which is equivalent to fd. Yeah, but let me tell you, in your moment, which is the vector formulation, we hardly can use scalar. You have to use the vector, which is ijk, and so the cross product. Yeah, things will be a bit complicated compared to what you have done before. Yeah, I'm going to remove this highlight. Okay, so if you see here, okay, if you see here, yeah, can you see r cross f? Yeah, r cross f. Yeah, r cross f. Sorry, I did something. Okay, I don't know whether, oh, wait a minute. Let's try this. Okay, sorry for this. I'm going to exit out. Okay, done. So if you see here, r cross f, can you see? So we have an f which is actually floating somewhere in mid-air. If you want it to have a moment about axis O, what you do is you connect O to R. It can be to the middle of f, or to the edge of f, or to the cap of f, as long as it is r. So from the previous lesson, you know how to find your r, isn't it? You find your coordinate 0, 0, 0, and then you have the coordinate of this down here. So you can find the unit vector of this r, and then this f also has its own coordinates. So from here, you can actually form this form of sort of like a matrix, yeah, r cross f. See, you arrange I, j, k, rx, ry, rz, fx, fy, and fz. This is what is very important for your exam, this part. Yeah, okay, how's the working? Once again, this is not maths class, this is static, so I only look at the final answer. But there are some cases where you can actually have more than one moment. So that's the reason why you have to use this method. You have to use your Cartesian method, yeah, where you can have r1 cross f1, r3 cross f3, r2 cross f2, where at the end of the day, everyone will have their own set of ijk, ijk, ijk. You add up all the i's together, you add up all the j's together, and all the k's together, and you can solve the question. Okay, so now I'm going to go into one example here. I'm going to show you the example 4.3. Okay, so pay attention. This can be a bit tricky because this is the application of your lesson, okay, of your maths lesson. Okay, so what do you have here? Let's look at this. Determine the moment produced by force F. So what do you have here? F is at 2 kilonewton, and then we have it's along AB, which you can find the unit vector of UAB. You know how to find the unit vector of UAB? You take the coordinate of B, okay, minus with A. Remember the last lesson? Yeah, that's very important. Yeah, you need to know how to do that. Okay, yeah, and then we have the O here. So you see, like what I say, the R is actually valid from any line along this O line here. So your R can be anything that's connecting to here. So it can be OB, okay, or from A to, yeah, from A to this line also can. R, yeah, this is R also. Up here will be RA, down here will be RB. Can you understand? Yeah, because as long as it connects to the line. Come, let me just redraw this to make you clear. Okay, so you see, this is your force, correct? Yeah, this is the force. Remember what I told you about R? R can be anywhere. Here, here, here. But I will not want to take in the middle because I do not know the coordinate here. So that's the reason why I don't want to do the middle part. So what I do is I stick to the edges, because the edges I know the coordinate, which is RA. I know the coordinate A, which is 0, 0, 12. And I know the coordinate B. Yeah, B. What is the coordinate of B? So what do we have here? We have 4 and 12, right, and 0. So B will be 4, 12, 0. And A will be 0, 0, 12. That is the coordinate. The unit vector will be you know how to find your unit vector, right? To form this, yeah, I've taught you in the last lesson, yeah. So this is how RA is 12k, and this is RB 4I plus 2j. Okay, now let's go to F. The F that's given to you is actually in the form of magnitude. Yeah, it's not sufficient, because for cross product you need to cross between vector and vector. Yeah, both have to be vector, which means what you have got here is actually magnitude. You need to convert this 2 into ijk. Okay, so this is the step. Can you see this? This 2, yeah, 2 is the magnitude, and then you need to find UAB. So how do you find UAB? Okay, remember, coordinate B minus with coordinate A on top. So in B, 4 minus 0, this is 4 minus 0, this would be 12 minus 0, this would be 0 minus 12. That's why it's it is what do you call, negative. And then divided by the magnitude of 4 square plus 12 square plus 12 square. So when you divide and you multiply with 2, you get this. So this is the vector for F. Now with this value, you can actually cross. Yeah. So to get the moment about point O, you have got two options. One option is to take your RA cross with this F. Also can, because this is here like this. Also can. Yeah. So this is the option. The green box is this option, where you take RA cross with F. Okay. So the answer that you get is negative 16.5. Now the second option will be the one in the pink. Okay, where you take RB and you cross with the F. So this is the second option. Both the options will have to give you the same answer. If it's not the same answer, then something would have gone wrong. Yeah. Maybe when you're pressing your calculator also. It must be the same value. Okay, so with that, try answer all the questions that I've given you as an exercise and upload it. Yeah. Okay, thank you.